Now, consider the list of the following numbers. We have to write down from this list all the numbers that are whole, integers, rational, irrational, and real numbers. So let's get started. I'm going to go ahead and start with whole numbers, okay? So from my list, I'm going to go down the list. You guys will tell me yes or no, okay? Square root of 3, is that a whole number? Is the square root of 3 a whole number? No. Negative 1 over 3, is that a whole number? Nope. The cube root of negative 8, is that a whole number? Nope. The square root of 9, whole number? Ooh, I see one yes. I see two yeses. Well, how much is the square root of 9, guys? What's the square root? It's 3, so that is a whole number. Okay, so we have our first one, square root of 9. Next, 0 divided by pi, is that a whole number? What's 0 divided by anything? What's the answer? 0. So I go back to my question. Is that a whole number? What are whole numbers, guys? Remember, it is all the counting numbers, including zeros. Pamantla, that's the other way around. Okay, you can say 0 divided by something, but you can't say something divided by 0. You'll see between these two that we're doing over here. These two guys. So 0 divided by pi is a whole number because my answer is 0. Okay, now we get to pi divided by 0. And that is undefined. Okay, so that is definitely not a whole number. Pi divided by 8, is that a whole number? Is pi divided by 8 a whole number? Nope. What about the square root of negative 4? The square root of negative 4? No. 3 comma 6 recurring? Nope. 0 comma 9 recurring? Nope. And 22 divided by 7? No. Right. We only have two whole numbers in this whole list of numbers, guys. Imagine. Right. Let's get to integers. Back to integers. And remember, integers are the set of positive and negative numbers. Now I'm going back. Square root of 3. No. Negative a third. Negative a third. Does integers include fractions? Does integers include fractions? No, it doesn't. So that is definitely not an integer. The cube root of negative 8. What is the answer for cube root of negative 8? Remember, this is not a square root. It's a cube root. Thank you. The answer is negative 2. Is that an integer? Yes, it is. See, guys, you guys must check. Negative 8. Square root of 9 has to be because it is a whole number. Okay, these two we've established they're not integers or whole numbers. Neither is this. Pi, 0 divided by pi is though. Excuse me, 0 divided by pi is because it is 0. The answer is 0, which is part of integers. And those are all the integers that we have here. Okay, now let's move on to rational numbers. I'm going to change this to unreal numbers. Rational numbers. All right, remember those are recurring decimals, terminating decimals, or numbers that can be written as fractions. Those are rational numbers. So I'm starting again. Square root of 3. No. Negative a third. Yes. It's a fraction. So it's rational. Cube root of negative 8. Cube root of negative 8. Yes. The answer is -2. Next, square root of 9. Yes. 0 divided by pi. Yes. This is our longest list yet. Pi divided by 0? No. Pi divided by 8? Pi divided by 8? Remember, pi is 3, 1, 4, blah, 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 blah. If you divide that by 8, you're going to get an even longer decimal. So that is definitely not rational. Square root of -4. Square root of -4. No. 3, 6 recurring. Laura says yes. Laura, can you square root a negative number? Are we allowed to square root a negative number? No. There we go. Okay, 3, 6 recurring. Is that a rational number? Yes, it is, because it is a recurring decimal. 3, 6 recurring. 0, 9 recurring. Is that a decimal number? Is that a, excuse me, rational number? 0, 9 is indeed a rational number. And 22 divided by 7, who knows what that is? 22 divided by 7 is what? It isn't rational, but what do we use that for? Sometimes we use it for pi. Did you guys know that? Sometimes pi, there we go, Sengane, we use it for pi. Okay, number 4 is irrational numbers. So I'm going to skip all the rational numbers because if they're rational, they're definitely not irrational. But I'm going to start with the first one, which is the square root of 3, because we didn't say it was rational. So is that irrational? Yes, it is. Finally, square root of 3. Okay, I'm going to skip. Pi divided by 0 is a tricky one. What would you guys say that is? Pi divided by 0. It is not non-real. It is not irrational. Undefined. It is undefined, guys. Okay, be careful with the vocabulary. It is undefined, meaning there is no definition. We do not know what happens when you divide by 0. Okay, right. Pi divided by 8, is that irrational? Yes, pi divided by 8. Square root of -4, is that irrational? Square root of a negative number, is it irrational? I need more responses. I have a yes and a no, and a yes and a no, and a no. It is unreal, so it is not irrational, guys. If you say it is irrational, you're saying it's unreal. Remember, all of these categories are under real numbers, so it is not irrational. It's a number that doesn't exist. It's an imaginary number, which is exactly what actually they call it. But you guys will do that in university, okay? So it is not irrational, it just doesn't count. And then finally, 22/7. Yes. Now I changed number 5 to unreal, and there's only one number that we said was unreal, which is which one? Which one is unreal? Nope, that is undefined, not unreal. That would be the square root of -4. Okay. This one is undefined. We do not know what happens when you divide anything by 0. So we call this undefined. Okay, great. That was a warm-up for our brains, a nice warm-up. Now, if you remember, the next thing we did was a bunch of integers. So I'm going to need your help doing this. Is there anyone who's feeling confident enough to speak today? Anyone who wants to raise their hand and do these with me? You'll only do one. Don't worry. I won't overwhelm you. Anyone? There we go. Pamandla.
Hello, ma'am.
Hello. Are we going to do the first one together?
Yes.
Let's go for it. Kate, what's right?
So, -3 plus 6 equals to positive 3.
Okay.
And then a positive and a negative times it equals to a negative. So you say 3 minus 9,
Mm-hmm.
which will then equal to -6.
Nice. Thanks, Pamandla. That was beautiful. Beautifully done. Where did all my other hands go? Hey, these people. There we go. Thanks, Charlie. Hello.
Hi, ma'am.
We're doing number 9 or number 5.
Number 9.
Okay, let's go for it.
So it equals to -4
Mm-hmm.
minus 9 because
Because
a positive times a negative. Oh, board math. Okay, so now I'm not sure.
okay, I'm gonna leave this plus over here. This plus is the same plus that's over there. Do you see it?
Yes, ma'am.
Okay, let's divide these two guys together. -9 divided by -1. And negative divided by negative is going to give us what?
Gives you positive 9
A positive answer. And what's 9 divided by 1?
is 9.
9. Okay, now we have plus plus. Two positives give us
A positive,
plus 9. So what's -4 plus 9?
which equals to 5.
5. Beautiful. Nice. Okay. Motebang?
Yes, ma'am.
There we go. You ready?
Yes, ma'am.
Which one are we doing?
Number 14.
Okay, let's go for it.
And is 1 plus -9. The positive and the negative equals a negative. So it's 1 times 1 minus 9.
Okay. And what's 1 minus 9?
-8.
-8. Beautiful, Motebang. Beautifully done.
Thank you, ma'am.
Okay, let's see who's next. Leachilwe, are you ready?
Yes, ma'am.
Okay, which one are we doing?
Number 5.
Number 5. Let's go for it.
So, -5 times -1. So we know that a negative times a negative is a positive. So it's going to be -1 plus 1.
Oh, we're over here. Sorry. For a while, I was like, what? Okay, so must I just rewrite the rest of it the way it is?
Yes, ma'am. That's what I did.
Okay, -1. And then you said plus 1.
Yes, ma'am.
Okay, let's continue from there.
So we got for board math, we do times first and then additional subtraction. So we're gonna say -5 times -1. Then it gives us a positive 5
Mm-hmm.
plus 1.
Plus
And then
1.
it's like the answer of 6.
Beautiful. Nicely, Achille. That was brilliant. Beautiful, beautiful. Okay. Last chance, guys. We still have 2 more questions. Anyone want to do the last 2 with me? Nope. Come on, guys. You know them. It's fine. Let me do number 10. Let me do number 10 with your help. Okay. So BODMAS says we start inside the bracket. And there we have a bracket there. So we have to go inside this bracket. Now we have this positive negative situation over here. A plus and a minus give us what? Plus minus is going to give us a negative 4 and then divided by negative 3. Right. What's 7 minus 4? Remember, we're still inside the brackets. It is 3 divided by negative 3. A positive and a negative. If I'm dividing, my answer is going to be negative, and 3 divided by 3, 1. Okay, you guys can do this. Let's do number 15 quickly together. Again, we have brackets there. So we have to go inside the brackets over there. Okay, so I'm going to rewrite my negative 1 minus, and yes, Seth, that's going to give us a negative. So it's negative 9 minus 3. How much is negative 9 minus 3? Negative 9 minus 3. Is it just 12? It's negative 12. Okay, now we're back to plus minus of negative, excuse me, over here. 2 negatives are going to give us a positive plus 12. So my final answer is 11. Beautiful. Remember, it's not minus, Pamandla. We're going the other way. Yes, there we go. Okay, thumbs up, thumbs down. Are we all good with what we've done so far? Screenshotters, this is your chance to do your thing while I take a thumbs up, thumbs down. To everyone who's new, you go to reactions. If you understand, you give me one of these. If you don't understand, you give me one of these, and then I'll explain nicely to you. Okay, I see thumbs up only. Thumbs ups only. Okay, now let's move on. Now we're going to do BODMAS still, but with fractions. Okay, so here's my first fraction. Where do I start again with BODMAS? Brackets, inside the brackets. There. Luckily, we don't even need to find the LCD because we already have the same denominator. So I'm going to rewrite 3 over 5 times, what's 1 over 5 plus 4 over 5? 5 over 5, which we can rewrite as what? 1. So it's 3 over 5 times 1. So then my final answer is? My final answer will then be what? 3 over 5 times 1. Anything times 1 is the number itself. So 3 over 5 times 1 will then be, there we go, 3 over 5. Nice. Okay, we have brackets again. There's just one thing that's different over here, but we'll see. We'll get to it just now. But we need an LCD first. We need an LCD inside my bracket. What's the LCD between, well, 4, 2, and 5? Nice. So my LCD is 10. So I'm going to rewrite this. A half plus 3 over 5 divided by 2 over 9. Take note, I rewrite everything. Do not leave this 2 over 9 out, because if I'm your teacher, I'm going to be very sad if I see you guys doing that. I'm going to take away marks. Okay, now let's see. What do I have to times 2 by to get to 10? But what I do at the bottom, I do at the top. What do I have to times 5 by to get to 10? By 2. Nice. Do at the bottom, do at the top. What are my new fractions inside the brackets? my new fractions inside the bracket. 5/10 plus so it's 5/10 plus 6/10. Thank you. Divided by 2/9. What's 5/10 plus 6/10? Nice, guys. I'm loving the participation. We are flying. Divided by 2/9. Great. Now, how are we going to solve this one? Flipping times. Nice. Keep, change, flip. So we're going to keep 11/10. Okay, I'm going to go to the side here just for space reasons. 11/10. I'm going to change my division sign to a what? My division is going to change into a multiply by 9/2. Are there any common factors? Is there anything that we can cross cancel over here? No. So we just have to multiply through. So what's 11 times 9? 99 over what? 20. Okay. I want us to change this to a mixed fraction. How many times will 20 fit into 99? 4 times. And my remainder is? My remainder is? No. Remember, 2, 4, 6, 80. My remainder is 19/20. Remember, 4 times 20 is 80. So you remember, remainder is 19 because that's what's left over from 80. Okay. Let's do another one. Okay, I'm going to need some space for this guy. Whoop. There you go. Okay, where do I start with this one? Where am I going to start with this one? Cross multiply. Yes, we're starting with multiplication. Okay, where are my common factors? Do 2 and 4 have a common factor? Yes, and it is 2. 2 goes into itself once and into 4 how many times? Twice. So my new fraction over here will then be 2/9 plus, I should probably leave space, plus 2/5. What's my LCD? Beautiful people. We are flying through this and I love it. My LCD will then be 45. That means I have to times 9 by what? By 5. And I have to times 5 by 9. Okay, let's write my new fractions down. I know they're both going to be over 45. Okay, first one is what over 45? 10, and my second one? 18. So what's my final answer? My final answer is 28/45. Can we simplify this? No. That's our final answer. All right. How do we feel about this? Let me zoom out for screenshotting. Thumbs up, thumbs down for this section for fractions. How are we? Remember, this was revision. So if it feels too easy, it should. But if you still have something you're unsure of, now is the time to ask before we move on to a different, completely different topic next week. Okay. I am going to skip right past my brain break because I need us to work a little bit. We'll come back to the brain break when I'm ready. Okay. Okay, this is an interesting guy over here. Any suggestions about where we can start? Brackets. Beautiful. Now we have brackets inside of brackets. So we have to start with these brackets that are inside the initial brackets. Okay. So I'm going to rewrite everything else the way it is. Cubed times a third divided by open brackets. What's my LCD between 4 and 9? 4 and 9. My LCD is 36. Okay. We're going to do a lot of times in here. Plus 8 over 9 minus 3 over 4. Close, close. Okay, what am I timesing 9 by to get to 36? 4. And again, 9 by 4. And 4 I'm timesing by 9. So we're going to rewrite all of this so I can write my new fractions. If this feels tedious, this is what your maths teachers expect. Don't do sums in bits and pieces. You must write everything. Okay, so my first fraction is, thank you very much, Seth, 20 over 36 plus what? $20 over 36. The second one is 8 times 4, which is 32 over 36. And 9 times 3, 27 over 36. Again, I'm rewriting everything. We're inside the bracket now, right? So I have 20 plus 32 minus 27. That is what over 36? $20 plus 32 is 52. Minus 27 is... Oh, I've lost the chat here. 25. Yes, it is 25. Okay, we have worked through the first brackets. Now we are going to work through the second brackets. Again, a half, third times open brackets. Keep, change, flip. Beautiful. You guys are ahead of me. Divide becomes a multiplication, and I flip this around to be 36 over 25. Do we have a common factor between 3 and 36? And the common factor is what? It's not 11. What's the common factor between? There we go. It's 3. 3 goes into itself once and into 36 12 times. Okay. Of course, I'm going to write a third because I'm thinking of 3. My dog is greeting you guys again. Times, open brackets. 1 times 12. 1 times 12 at the top is 12 over 1 times 25. I'm going to say 27 over 1 times 25 is 25. We're finally done with that. Now we're going to deal with the new movie, which is this one. 1 over 3, 1 over 2, excuse me, cubed. Okay, this is the same as saying 1 over 2 times 1 over 2 times 1 over 2 times 12 over 25 equals. Let's work with this guy over here. What's 1 times 1 times 1? That is 1. Thank you very much, Seth. 1 over, what's 2 times 2 times 2? 8. This is going much faster than I anticipated. Over 25. We are on our last step. Maybe. Okay, can we cross cancel here? 8 and 12? 8 and 12 don't have the same factors. Think about it, guys. Is there no number that can go into 8 and into 12? There is 2 and what else? 4. Okay. 4 goes into 8 how many times? Twice, and into 12 3 times. So final answer is 1 times 3 in the numerator, which is 1 times 3 is 3 over 2 times 25, 50. And we are finito. How do we feel about this one? Give me a thumbs up or a thumbs down in the reactions or in the chat. Okay, I'm seeing your thumbs up going up. I'm liking the amount of thumbs up I'm getting. I'm liking the amount of reactions I'm getting. Okay. You guys are moving fast. You smart, smart children. Yo, you guys must come be my children where I teach. Okay, I see someone gave me one of those, which means you're sort of there, but not really. I'm not sure who that is. Do you have a question so I can clarify for you? Yes, you are. I'm so proud of you guys. Actually, I'm so proud of you guys. I'm not sure who it was, guys, who gave one of these. That means you're not sure. Yeah, 2 seconds to ask question. 3, 2. Okay, it's fine. Okay, I think we deserve a brain break. Okay, does anyone want to unmute and talk to me for the brain break? There we go. Hello, Sinyane.
Hello, ma'am.
Would you rather have bright purple hair or purple teeth?
Bright purple hair.
Why not teeth?
Because it looked like you ate something and then it's like stuck in your mouth and you didn't wash your teeth.
Ah,
Brush your
hectic.
teeth. Yeah.
Wow, guys, I swear it looks like you didn't brush your teeth. I feel like Kirini would get purple hair either way. Like, doesn't have to be a would you rather game. I will get purple hair any day type of thing. Even Rowa says, wow, purple hair. Okay, guys, team purple hair. It's fine. People are gonna make fun of us. Woo! Guys, we'll get purple hair. I'll even get purple hair. And then we can rock it. Ah, Lomso, we'll get you a wig. A purple wig. How's that? Wow. Okay, the next one. Would you rather only go to school in summer or only go to school in winter? So which season do you prefer going to school? I saw so many winters. I'm concerned. Guys, don't you guys feel tired in winter? Like, I don't want to go anywhere in winter. I would rather go in summer. Yeah, I wouldn't. No, guys, I'm not reliable in winter. I just get home and I want to rest and I want to relax. So thinking of doing homework and oh, I'm so dark in summer, Sanandi. Hectic. I'm not lazy in summer, guys. I can't sleep in summer, which means I must stay up and work. So, you know, yeah. Would you rather have an unlimited gift card from McDonald's or from the cinema? And that includes snacks. Your unlimited gift card is including snacks. McDonald's, cinema. I'd also pick cinema, guys. I'm not gonna lie, I would choose cinema. Have an outing now and then, go watch something. Even if I rewatch something, it doesn't matter. Exactly, Seth. And you have unlimited. You can keep going to ask for more. You can leave a movie and go right back into another movie. Imagine, guys, you can watch whatever you want and you can eat whatever you want at the cinema. I feel like they should make cinemas that have like chip and dip. Do those exist yet? I'm not sure. Like a chip and dip where you can get like those chips and like sauce and like so that you have a choice. You don't just have to have popcorn. They exist. Oh, I want to go to one of those. So you can go in the cinema with your chips or with your like, what do they sell at chip and dip? Samosas and just like have fun. And the last one, would you rather have a huge pimple or a huge booger show on a school photo? So imagine you take a nice photo and you really think I aced it, and then your photo comes back. I see people picking pimple. Wow. Hectic. Hectic, guys. Ilom's was like, nope, I don't want either of them. Ah. Seth, I'm wild. Okay. I can put a sticker or plaster. What if you were sick that day? And like, guys, don't judge, man. Things happen. Okay, I'm done laughing. I'm done. The booger is like, you see it. Like, it's visible. I'm done. I'm done, guys. I'm done. Oof, that was a good laugh for me. That was a great laugh. And imagine the pimple is here. Like not on the side, not like, but like right on the focus of your face. Mm, okay, guys, let's stop it. Let's stretch. Let's have a nice stretch. Oh, I just stretched my shoulder. I was like, oh, oh. Okay. Are we good? We're good. Okay, some of these we've done already. I think B we did. Yes, we did B. So we're gonna do A and C and D. We'll see how far we get. We'll see how far we get. Okay, let's start with A. John asks Tabo how many learners are in his class. Tabo answers, if you take twice our number, plus half our number, plus a quarter of our number, plus 1, the answer is 100. Right, so we don't know how many learners there are. So what are we going to use in place of the number of learners in the class? What do we usually do in maths if we don't know the number of something? Thank you, Senyani. We just say X, okay? But if you're going to write this in a test, you must say that the number of learners is X. So you must tell the teacher. Don't just start using X out of nowhere without explaining what this X is, because the question doesn't have a variable. So if you introduce a variable in an equation or a expression or whatever, you must tell the teacher, look, I'm making the number of learners equal X. Okay, we have done that. Step 1 is taken care of. Now, if you take twice our number, twice means what? What are we doing? Twice our number times 2. So I'm just going to say 2x because that's the same as times 2. Okay, so that's twice our number. Plus half our number. What are we doing if we say half our number? What are we doing if we say half our number? Half of x. So we're dividing it by 2. Are you guys with me? plus a quarter of our number. What are we doing when we say quarter of a number? This is the half. What do we do when we say a quarter of a number? By 4. So we're going to say x divided by 4. You're still with me? Okay. And then it says plus 1. All of this has to equal what? All of this that we just did has to equal what? 100. So now we're having a little bit of a crash course in algebra, right? So all of this has to equal 100. Now I have x here and I have a number sitting there on its own. Let's first simplify the x's because they are the ones that are the like terms. So it's like saying 2 plus a half plus a quarter. How much is that going to give us? 2 plus a half plus a quarter, because that's what we did basically, right? 2x plus half a x plus a quarter x. And that gives us, maybe I should write it on the side nicely so that nobody gets confused. 2 plus a half plus a quarter. There we go. This is going to give us 11 over 4 what? 11 over 4 x. Thank you. So this is 11. Okay, I'm going to say 11x over 4. It's the same thing as 11 over 4x. Plus 1 equals 100. Now I want this guy to be on his own on the left. Let me stop using yellow. It's giving me a headache. Right. So what am I going to do to this 1? We have a 1 that's just chilling there. How do we get rid of this 1? To the other side. And when it gets to the other side, thank you, Leachilwe, it's a negative. So now we have 11x over 4 equals 100 minus 1. So 11x over 4 equals 99. Now we have 2 more numbers to get rid of. How do I get rid of a divide by 4? What is my inverse operation? Thank you very much. So now we are on divide by 4. So I times by 4 on this side and I times by 4 on that side. These will cancel out. I'm left with 11x equals what? What's 99 times 4? 99 times 4, 396. And finally, I have a 11x to get rid of. How am I going to get rid of 11x? This guy over here, this 11. Nice. Divide by 11, divide by 11. Therefore, there are how many learners in the class? 36. How do we feel about that one? Thumbs up, thumbs down. Okay, I see a few thumbs up. I feel like we're hesitating a little bit. It was a bit challenging, wasn't it? It was a bit challenging. Okay, we still have time. We still have time. Okay, let's go to C. In a certain school, we already did B, remember? Let's go to C. In a certain school, a test counts 20% of the year mark, and the year mark counts 25% of the final mark. What fraction does the test count on the final mark? Okay, so in the first place, okay, I'm going to have to move. This is number C. Let's do this. Whoop. Whoop, whoop. Number C. Okay, so this test counts 20% of the year mark, and the year mark is 25% of the final mark. So we actually have to find 25% of the 20%. Do you guys agree? We need the 25% of the 20%. Are we with me? I feel like I might have lost some people here. Is there anyone who's confused? Spamanda says yes. Okay, Spamandla, listen, okay? So this test is 25% of, oh, I was about to get right into it. It's fine. Okay, so we need to find 25% of the 20%, right? Because this 20% only counts 25%. So a quarter of the 20%. Okay, Seth. So look, let's say we have a year mark. Okay. We have a year mark. And this year mark comprises of 100%, right? 20% of that is what we want. You're with me, right? But this year mark for the whole year is only 25%. So there's a whole 75% that's there. This whole year mark is just the 25%. So you have to times these together to get the final percentage that it counts. Okay, so you need to find, so, okay, think about it like this. If you had gotten 100% in this case, right? For the year, final mark, you would have only gotten 25 because the whole 100 only counts 25. Are we with me? But you didn't get the whole 100. You only got the 20. So you have to say, then I had to find out what is 25% of that little 20 that I got. Are we with me? I feel like I'm finding a lot of us here. We are coming back. Beautiful. So now do you understand why we have to multiply them? Because it's the 25% of the 20% that you got. Okay. Beautiful. Okay. So 25%, remember, is over 100. And I'm going to multiply it by 20 over 100. Are there common factors over here? Yes. 25 goes into itself how many times? Once, and into 100. 4 times. 20 goes into itself once and into 100. 5 times. Okay, what's 1 times 1? 1. And at the bottom, we have 5 times 4. 20. Now let's convert this to a percentage. Okay, we actually don't have to because they said what fraction. What fraction. So then that test will actually only count 1 over 20. Okay, Leachile does want to make it a percentage. Let's do it. Times by 5, times by 5. It's going to be what? If I times by 5, it's going to be, it's actually only 5% of the final mark. Are we with me? Did everyone get what I said? I still have time to explain. Give me a thumbs up or a thumbs down. I think this is a beautiful place to end the lesson.